Hello, everyone. I'm Jason Mays, Web AI lead here at Google. And I'm also joined by my colleague, Nali, who's our on-device machine learning tooling lead, who'll be talking in just a few minutes. Oh, my clicker. Now, I want to start by formally defining what Web AI actually is. This is the art of using machine learning models client-side in the web browser, running on your own device's CPU or GPU, by using JavaScript and surrounding web technologies like WebAssembly and WebGPU for acceleration. This is different from cloud AI, whereby the model would execute on the server side and be accessed by some kind of API. And as you may have guessed, a lot has changed in Web AI since 2023. So I want to start by highlighting key areas you'll learn about in today's talk, as we'll be giving updates from a whole bunch of Google teams working in this space. You'll go from learning how to run our brand new large language models in the browser at incredible speeds with no server-side calls after the page load, to showing you the impact of running models client-side to make your company even more cost-effective when creating real business applications like video conferencing. Or what about going from idea to prototype faster in our new collaboration with Hugging Face, to a taste of the future where you can talk to Visual Blocks, our low-code framework, and have it build a pipeline for you in seconds using our latest research publication. And we've even got updates from the Chrome team for how they're enabling JavaScript developers to leverage Web AI at Chrome scale, using technologies like WebGPU and WebAssembly, and even new AI-focused APIs at the browser level. So with that, let's get going. First off, what difference does 1 year actually make? Well, we're pleased to announce that we crossed 1 billion cumulative downloads of MediaPipe and TensorFlow.js libraries and models for the first time. In fact, over the last 2 years, we averaged 600 million downloads per year, bringing us to over 1.2 billion downloads in that time frame. And we're on track in 2024 to continue that growing of usage. Now, focusing in on the TensorFlow.js library alone, you can see the steady rise since 2020 in this graph from NPM, where developers really started investing in Web AI. Now note that this graph shows weekly downloads, so we're currently seeing around 1.1 million monthly downloads just via NPM. And shifting to the next chart, this shows the number of content delivery network downloads from JS Deliver just for the month of January 2024. We had over 11.8 million downloads of a library in that time. And again, we expect to see usage increase over the coming year as Web AI is explored by more developers than ever before in production use cases. Now, what does this mean for business? Well, in addition to a better user experience due to reduced latency, when you bring an AI model into the web browser, you also gain privacy for the end user, along with significant cost savings too. Let's take video conferencing as a solution, as an example. And many of these examples of a video conferencing provide background blur or background removal in video calls for privacy. So let's crunch some hypothetical numbers for the value of using client-side AI in an application like this. So first up, a webcam typically produces video at 30 frames per second. So assuming the average meeting is 30 minutes in length, that's 54,000 frames you've got to blur the background for. And assuming 1 million meetings per day for a popular service, that's basically 54 billion segmentations every single day. Now, even if we assume a really ultra-low cost of just 0.0001 cents per segmentation, that would still be $5.4 million per day, which is around $2 billion a year for server-side GPU compute costs. By performing background blurring on the client side via Web AI, that cost goes away. And don't forget, you can even port other models to the browser too, such as background noise removal, to improve the meeting experience for your users while still getting all those benefits. Now, speaking of production use cases, 2024 has been quite the year for bringing Gen AI to the browser by the wider JavaScript community. And we at Google have some new offerings too. First up, I want to speak about Gemma Web. This is a new open model that can run in the browser on a user's device, built from the same research and technology that we use to create Gemini. By bringing a large language model to run on device, it can save significant costs of running on a cloud server for inference, along with enhancing privacy and reducing latency. In the example shown here, you can see how the user is able to generate an email to their friend for some given context and certain requirements without any of the text being sent to the server. Even better, this runs really, really fast. The demo you see here is captured in real time. Now, you can imagine turning something like this into a Chrome extension, whereby you can highlight any text on the web page, right-click, and convert it to some form that you can post on social media, or maybe define a word that you don't understand, all in just a few clicks for anything you come across, instead of having to go to a third-party website to do that. In fact, I did that right here in this demo that I made in just a few hours on the weekend, entirely in JavaScript, client-side in the browser. And there's so many creative ideas waiting to be made here. So from Chrome extensions that supercharge your productivity to features within the web app itself, we're at the start of a new era that can really enhance your web experience. And the time is now for all of you to start exploring those ideas. In fact, right now, GenAI in the browser is in its early stages. But as hardware continues to get better, with more CPU and GPU RAM becoming commonplace, we'll continue to see models like this ported to the browser on device, enabling businesses to reimagine what it can do on a web page, especially for industry or task-specific situations where the weights of smaller LLMs in the range of 2 to 8 billion parameters could be tuned for a specific purpose on consumer hardware. Which brings me to my next update, our brand new large language model inference API. This API supports 4 leading open architectures out of the box, accelerated by both CPU and GPU. All of these are easy to use via a common API to load and run right in the browser on device without any server calls after the page load by any front-end developer, and with speeds that are well beyond the average human reading speed. So let's learn a bit more about each of these. First up, we've got Gemma 2B. This is a lightweight, state-of-the-art open model that's well-suited for a variety of text generation tasks, including question answering, summarization, and even reasoning. We recommend using Gemma 2B that's available to download on Kaggle models and comes in a format that's compatible with our LLM inference API. If you take one of the other supported architectures on the following slides, you need to convert them to the runtime that can be used in our API using our converter library that I'll talk about in just a few slides' time. Next up is Phi2. This is a 2.7 billion parameter transformer model best suited for question-answer situations, chat, and code formatting. And we've also got Falcon RW1B, which is a 1 billion parameter model trained on 350 billion tokens using the refined web dataset. And finally, we've got Stable LM3B, which is a 3 billion parameter decoder-only language model pre-trained on 1 trillion tokens of diverse English and code datasets. So, with all that in mind, what's the performance like? As you can see from the table, depending on the client-side device you're actually running on and which architecture you choose to use, you've got different runtime memory usages and token generation speeds. However, it should be noted that it's estimated there are around 0.75 words represented per token. So that means our fastest tested setup reached around 64 words per second, and our lowest scoring setup is about 10 words per second. So given that the average human reading speed is around 4 words per second, this is still over 2 times faster than the average person could read. So that's probably good enough for most situations, and with time, this is only going to get better as hardware improves over time. In fact, one could envision a hybrid approach right now, whereby if the client's machine is powerful enough, you download and run the model there, only falling back to cloud AI in times when the device is not able to run the model, which might be true for older devices where the CPU or GPU RAM might be quite small. With time, though, more and more compute can be performed on device, so your return of investment should get better as time goes by when implementing an approach like this. Okay, so how hard is it to use? Well, it's actually pretty straightforward. In fact, it fits on a single slide, so let's quickly walk you through it. First, you're going to import the MediaPipe LLM inference API using the standard JavaScript import statement. Next, you're going to define your large language model, wherever it's hosted somewhere on the internet, and you would have downloaded that from one of the previous links on the slides. Once you've downloaded and hosted that model and set the correct cause headers, you can then use it in your web application. Now, you define a new asynchronous function that will actually load and use the model. And inside this, you can specify the file set URL that defines the desired MediaPipe runtime to use. Now, this is using the default one that MediaPipe provides and hosts for you, and this is safe for you to use as well. However, if you really wanted to, you could save this file on your own CDN or server and host it there too. Next, you can use the file set URL from the prior line to initialize MediaPipe's file set resolver to actually download and use the runtime for the GenAI task you're about to perform. Now you can load the model by calling llmtask.createFromModelPath, to which you pass the file set and model URL that you defined above. As the model is a large file, you must await for that to finish loading, after which it will return the loaded model, which you assign to a variable called LLM there on the left-hand side. Now you've got the model loaded, you can now use it to generate text just by giving some input text as a parameter, and you can store the text result in a variable called answer on the left-hand side there. And with that, you can then log the answer, display it on screen, or do something with the knowledge that comes back. Note, if you want to stream results instead of writing at the very, very end, you can simply pass a function in the second call there, which will stream partial results as they become available, which you can inject into your web page as they're available to get that nice streaming effect that you see on all the online web chat applications. And that's pretty much it. So now just call your init LLM function to kick off the loading process above and await for the results to be printed. So given that you now know how to load and run these models, we're also pleased to announce that by using any of these 4 architectures, you'll be able to load custom-tuned weights too, not just the pre-made ones that we've made for you. So that means you could distill or fine-tune your own versions of these models to one of these target architectures, and then convert that to the client-side model format, and be instantly able to run your own custom-tuned model right in the browser with comparable speeds to what we just saw, as long as your weights fit one of those architectures and is of the same size. To do that, learn more on the link shown to learn all about that. Okay, so as you've seen, the LLM Inference API lets you run large language models completely in the browser on the user's device for your next web application. You could use an LLM to perform a wide range of tasks that were previously just not possible in JavaScript alone, such as generating text, answering questions about a document that's being viewed, or even defining some text on the web page in a way you can then understand. And even better, you can do that at great speeds too. So check the link on this slide to go deeper into that API and try things for yourself. And we're looking forward to seeing what you all create. Now, on that note, if you do make something cool or manage to benchmark some of these LLMs on your own devices, we'd love to see your results. So use the community hashtag WebAI on social so we can share knowledge as a community. And this also gives you a chance to be featured at our future events. Next up, I want to hand over to Nali to talk about updates for the Visual Blocks framework that we launched last year, along with the collaboration with Hugging Face that we've both been working on. Thank you.
Thank you, Jason. Hi, everyone. Last year, we launched Visual Blocks, a no-code machine learning prototyping tool to enable developers and decision makers to work together when using machine learning. This allowed users to focus on the problem they're actually trying to solve, instead of being blocked by code complexity and technical barriers. All key features are neatly packaged in the node graph editor as shown. Out of the box, users can select from a suite of pre-made nodes to perform common useful tasks, like getting data from a webcam or microphone, or visualizing the outputs of an AI model. And when you drag out from one of these nodes, they can suggest valid things they're able to connect to. In this manner, you can quickly create an end-to-end prototype that you can share with your wider team, enabling anyone, anywhere, to try what you've made on their own machine with their own data and input devices, or even customize the flow as they need to explore other related ideas. Now this year, we're pleased to announce a collaboration with Hugging Face, who have created 16 brand new custom nodes for Visual Blocks, bringing the power of Transformers.js and the wider Hugging Face ecosystem to the Visual Blocks framework that you can now all use too. 8 of these new nodes run entirely client-side via WebAI. Let's walk through the Hugging Face collection to see the superpowers you can get out of the box that can help bring your ideas to life. First up is image segmentation. As you can see, you can pass the model an image and then click a part of the rendered image to reveal just the pixels that belong to the object you clicked on. Now, previously, ViroBlocks shipped with a person segmentation model, but here, Hugging Face have extended this ability further. You can click multiple areas on the image to then combine object segmentation and view the results in real time. So depending on what you want to segment, you can choose the most suitable model. For example, for portraits of a person, the face parsing model may be a good fit. But for clothing, the SegFormer Bezier Clothes model may fare better. Try them all out today via the link shown. Next, translation, a brand new node we did not have before. Here, you can take any piece of text, pick a language of your choice from the node's drop-down box, and then have your input text converted to the desired language. There are 5 variations of this model to choose from, depending on your requirements, with the smallest being 78 megabytes. Now you can imagine using this with other nodes to bring powerful ideas to life. Imagine you also have a node that can extract text from images. In that case, you can feed the text found from the image into this translation node to convert what you see around you in the real world to something you can understand when you are on holiday or abroad, just like Google Lens does, but in the web browser. There's a lot of potential to get really creative here, especially when combining with other ViroBlocks nodes. Next up is token classification. What's that? Well, given some sentence, it can extract words that are in some way meaningful, such as locations, companies, or names of people that are found in the sentence, as shown on this slide. Having the ability to extract useful information from a long sentence could help you perform a more powerful search or understand your user's intent in greater detail. Again, you can choose from several models depending on your needs. Moving on, you also have the hello world of machine learning, image classification, and object detection. You can select from 4 new classification models and 2 new object detection models, including ResNet and YOLO variants. It should be noted, many of these models were trained on the ImageNet 1K dataset that did not contain people in the training data. So while these models may not fare well on images of people, they're pretty good at finding animals and other objects, as shown in our example images. Switching back to text models, we also now have a new text classification node. This allows you to classify text based on sentiment or toxicity, for example. Right now, you can choose from the 3 models provided, depending on your needs, with the smallest being 67 megabytes in size. Next up, background removal. This model loves to remove background from an image. Now, some of you may be wondering, how does this compare to our existing body segmentation model? Well, the cool thing about this one is that it doesn't just focus on people. So as you can see here, when I remove the background with an animal in the foreground, it still works just fine. Pretty neat. So give it a try today using the link shown on the slide. Finally, we have depth estimation. For any given image, the model will try and estimate how far away each pixel is from the viewpoint. For subtle movements like you see here, this can help give the illusion of a 3D image using any regular 2D image. You can adjust the displacement amount using the slider in the viewer node to get an effect that works well for your specific image. Now, in addition to the client-side models on the previous slides, Hugging Face also supports several task-based nodes that execute a model of your choice via a server-side call using their own APIs. This means you can try thousands of models that fall under one of these supported task types that can now be all used within ViroBlocks too. So what are the task types supported? You can choose from fill masks, image classification, summarization, text classification, text generation, text to image, or even token classification. Now, as this talk focuses on client-side models, we encourage you to try these actual models out in your own time, as they could complement using web AI models in a hybrid manner. With time, I'm sure we'll see client-side variants being produced too, as devices continue to get more powerful. So head on over to the project page at go.gle/hf-ViroBlocks to learn how you can use the new ViroBlocks nodes from Hugging Face today. So how did Hugging Face make those custom nodes that work seamlessly with their own custom code and APIs? Well, today, we're pleased to announce custom nodes for ViroBlocks. Since launching ViroBlocks early 2023, we've spoken to many of you throughout the year, and time again, we saw requests for people wanting to run custom logic. But on that note, you wanted to be able to make custom nodes that could work with all our existing offerings, so you didn't have to start from a blank canvas, especially for common reusable things such as accessing sensors like the webcam or common output visualizations for vision or text models. So hello, custom nodes. Built-in nodes may not be perfect match for all use cases, but this is where custom nodes can shine. Even better, they're just regular JavaScript web components, specifically the custom elements implementation. So it's really easy to make the new nodes using your favorite frameworks or even no frameworks at all, as web components are part of web standards in modern browsers. Now, at this point, you may be wondering, what can a custom node do? Well, the short answer is that if you can write it in JavaScript, you can turn it into one. Maybe you have some custom client-side logic that can be turned into a custom node. Or maybe you want to call a new third-party web API on some remote server. That can be a custom node too. And with that, the nodes you create can work with all our existing ones and even other people's creations, assuming the input-output types match, allowing you to innovate faster by reusing the work of others. So come along and join our workshop this year to learn how to make your very own custom nodes from a blank canvas. For those of you here live, search for the workshop for ViroBlocks going on later today. And for those tuning in online, you can search for the recording or head to the Code Lab link shown to get at your own pace. Now we look forward to seeing what you all create. If you make a custom node and want a chance to be featured at our future talks, please tag your demo of it in action using the ViroBlocks hashtag on social. Now then, if you can create custom nodes that have well-defined inputs and outputs, what could the future of ViroBlocks look like as AI itself progresses? Today, we would like to share with you a research project called MediaPipe, which is a collaboration between many research folk here at Google to give you a taste of that future. Today, with ViroBlocks, to go from idea to working prototype, you can drag out and connect nodes to solve some tasks you have in mind. And this can be much faster than coding each block yourself manually, which is great. But what if we could build a co-pilot for visual programming to go one level higher still? Imagine you could type a sentence for what you desired, and the ViroBlocks graph would be made for you automatically, powered by the latest in generative AI. Let's take a look at our research project in action. Here, you can see the user simply types a prompt into the box, and the ViroBlocks pipeline is produced. Notice how it was not perfect the first time. So we modified the prompt to specify using a transparent image instead, and then we got the desired effect. Or what about this trip planner that was made with a quick prompt and a few user inputs to set it up once the graph was created? Here, most of the pipeline is completed, and they just enter their use case along with a valid API key at runtime to get the results for the city they desire. Using this approach, we were able to achieve around 81% reduction in user interaction, freeing up the end user to focus on the task they're actually trying to solve, instead of connecting wires to blocks. Here you can see one more example of this in action. In this case, we asked to turn the image of a tiger into a cat. But to do that, we use the PaLM API to describe the existing image first, and then use that to prompt Google's Imagine image generation model, which produces the output we desired that has a cat looking in a similar manner. Really incredible stuff. And this is just scratching the surface of what could be possible in the future, as multi-models continue to get better with time. So if you were excited by what you just saw, learn more about this research on the link shown to read our full paper. Next up, Model Explorer. If you spend a lot of time building, testing, and deploying ML models, you know how important it is to understand what's happening under the hood. For example, how nodes are related, how they are structured, and how they are performing. Google machine learning engineers face this problem every day. So we built a tool we call Model Explorer to make model debugging more intuitive and easier. Now we're excited to share Model Explorer with the world so that the entire ML community can benefit. Model Explorer supports multiple model formats, including JAX and TensorFlow, TensorFlow Lite, and TensorFlow.js files. Many teams in Google use Model Explorer in their daily work, such as Gemini, Chrome, and YouTube. So let's see it in action. Here, I'm demonstrating a GenAI diffusion model that can run in the browser. You can see that even navigating very large models is smooth, uncluttered, and low latency. We can navigate the graph layer by layer. Clicking on the layer highlights similar ones, saving you time and clicks. And the Properties pane gives you detailed information about each layer and node. We designed Model Explorer with usability in mind. Here's a few examples showing how you could leverage these features to enhance your debugging experience. First of all, we provide a bookmark feature that allows you to easily jump back and forth between different areas of the graph. Another notable feature is a color palette that allows you to annotate nodes with colors of your choice, allowing you to find similar nodes you care about easily. Model Explorer allows you to easily traverse, analyze, and debug machine learning models of almost any size and complexity, and is now free for everyone to use. To get started, just visit the link shown on the slide. Okay, now I will hand back to Jason to cover what Chrome has been up to.
Thank you, Na. So, next up, we've collaborated with Chrome, who've been investing in web AI as well this year. Now, I highly recommend you check out their I/O talks for all the details, but I want to give them a shout out for some highlights. Already in this talk, you've seen web AI in action, where it's loaded and run within the web page itself, like our Gemma large language model. But what if the model was already there for any site to use, built into the browser? That way, you wouldn't need to download your own LLM, and instead, it could be used across domains via a standardized JavaScript API. So imagine this. What if you could get the model to do what you need, like summarizing a large chunk of text on a web page, or a blog post, or whatever it might be, or make something technical easier to understand without having to master machine learning model creation skills? What superpowers could you all get as developers? Well, the web is so much bigger than our team. So we've been speaking to all of you about AI and its challenges to find out what's on your minds to help shape the future of AI in the browser. You can check the summary of our findings via the link shown on this slide, and we welcome further feedback if you've got ideas too, including thoughts on Chrome's built-in AI approach to solve the key challenges we've heard that you've been facing. Use the hashtag WebAI on social to tell us your thoughts. And on that note, we're also working on a new website providing guidance specifically for web developers choosing to use AI. With this site, we aim to help you understand key AI concepts so you can discover opportunities to use popular models to be more productive than ever, and to use GenAI to build delightful user experiences using existing tools, models, and APIs. Bookmark the site shown on this slide, as we'll continue to publish more content to here over the year. All right, going deeper down the stack, Chrome also have updates for Web GPU this year. We can now support 16-bit floating point values for GPUs that can support it. But why is that important? Well, as you can see from the screenshot, using 32 bits to store model weights for this very large language model resulted in around 11 tokens per second for decoding data. But by using 16 bits, this increased 45% to 16 tokens per second and uses half as much memory to store those weights. Next, updates for WebAssembly. I know a number of folk in the Web AI community have had issues creating web apps when you try and load models larger than 4 gigabytes in size. With the new Memory 64 proposal, there's now exploration to support 64-bit memory indexes, which would allow you to load larger AI models than you could do so before. Check the link for more details. Also, support for JSPI is now available to trial. That enables better interoperability between WebAssembly and other JavaScript APIs like WebGPU. This essentially bridges the gap between synchronous applications and asynchronous web APIs, which I know some of you will be happy to hear. You can keep track of this proposal and others on the link shown. Finally, in this section, Chrome is enabling its translation and speech recognition APIs to now work entirely offline, allowing you to go offline with your own web apps and to have these advanced features powering your user experience. It's great to see increasingly advanced features able to run on device, and I believe this is a trend we'll continue to see throughout the year and in the future, especially as models shrink in size for various tasks. So with that, do check out Chrome's talks on the web track to learn more about what they've been up to. Finally, I'd like to give out a shout out to something I know you all love to deal with, testing your AI models. Doing this on the server side is very well documented and fairly straightforward. But what if you want to test a client-side model in a real browser environment to see if it performs well using technologies like WebGPU and WebAssembly? Well, I'm pleased to announce I made a solution you can all try today that allows you to do just that for any Web AI application that needs WebGL or WebGPU support. Here you can see the difference in performance in the CPU on the left-hand side, which is what you get by default when running headless Chrome, versus the GPU on the right-hand side when Chrome correctly uses the server-side GPU. As you can see, this can seriously increase your testing speed and allows you to verify even larger Gen AI models that they correctly work in these browser environments before you actually make it public to the world to use. Now, if you need to test Web AI models in a more scalable and reproducible way, then head on over to our blog post write-up to learn more, or grab the code yourself from GitHub to help you on your testing journey. And with that, that's a wrap for this year. We really do look forward to seeing what you create with Web AI. 2024 is shaping up to be a great year for progress in the field, from Gen AI running locally to performance improvements across the board. And remember, do tag us in anything you create if you've got any suggestions for any of the technologies you've seen in today's talk. Feel free to connect with us on social media if you prefer, just search our names. And with that, thank you and see you next time.